We have one more question. Based on this question, we have the steel railroad track, and we need to determine the normal stress in the rails in two different cases. One, when the rails are welded to form a continuous track, and B, when the rails are 10 meters long with 3 millimeter gaps between them. In part A, we can simply write that because we have the one continuous member track, that's why we can say that for finding the normal stress, sigma is equal to E epsilon, Hooke's law. Yes, we can write, E epsilon delta L divided by L. Delta L is the length changes due to the temperature. We can write delta L due to the temperature, alpha S, delta T, and times L, original length. That's why we can say delta L divided by L is equal to alpha S delta T. Delta L divided by L is equal to alpha S. Based on the question data, we have 11.7 times 10 minus 6 times delta T, the changes in temperature from 6 to 48 is 42. And finally, we can say that delta L over L is equal to 4.91 minus 4. After finding the delta L over L, because we have L, E, we can find sigma is equal to 200 gigapascal to megapascal times delta L over L, or epsilon, 4.91. Finally, we can say sigma, or normal stress, is equal to 98.2 MPa. This is part A, when we have the continuous track. For finding the normal stress, sigma is equal to E epsilon. We have just one member. We need to determine the length changes because of the temperature. Yes, delta L is equal to alpha S delta T L. And finally, we can find sigma here. Part B. For part B, we have different members, different tracks with the 10 meters length and 3 millimeters gaps. For example, we have this condition. You can see, for example, here is that 10 meter, and these gaps are just, for example, 3 millimeter. In this case, for example, we need to write the compatibility equation for finding the normal stress. Compatibility equation in this case, we can write, for example, part B. We can write gap is equal to sigma, compatibility equation, CE. Gap is equal to sigma deflections that close the gap minus sigma deflections that open the gap. Now we have the one compatibility equation. CE gap is equal to sigma deflections that close the gap minus the deflections that open the gap. You know that the gap is 3 millimeter. The gap is 3 millimeter. Again, the gap is 3 millimeter. Deflections that close the gap are thermal deflections. In fact, deflections that close the gap are the thermal deflections, and thermal deflections close the gap. We need to find the thermal deflections for each member, for example, in each track, 10 meters length. We can find, for example, here, delta L is equal to alpha S delta T L. We say that delta L is equal to alpha S delta T. In the previous section we found that 4.91 10 to the minus 4 times L 10 meters. Yes, 10 meters to millimeter. It means that the changes in the length because of the temperature is equal to 4.91 millimeter. In this compatibility equation, the gap is 3 millimeters. Deflections that close the gap, in fact, thermal deflections close the gap. And that's why we can say this part is 4.91 millimeter. And the deflections that open the gap. Deflections that open the gap. In fact, when the members, these members for example, contact each other, then they press against each other. And forces are generated that want to open the gap. For example, here in the opposite direction, this force, for example, F, are generated that want to open the gap again in the opposite direction. For finding these deflections, for example, we can write delta is equal to PL or FL divided by AE. Yes. That's why here we can say 3 millimeter gap is equal to 4.91 minus P is unknown times L, the length of the member, 10,000 times A, E, 200. We know that P divided by A is sigma. Yes, that's why after the simplification we can find sigma is equal to 38.2 MPa. We found normal stress in part B. I mean, when we have different tracks, 10 meters with 10 meters length and with 3 millimeter gap. Let's review the solution again. We have the steel railroad track. We need to find the normal stress in the rails in two different cases. One, when the rails are welded to form a continuous track. We have just one member. It is necessary just we find that delta L, the changes in the length because of the temperature. And after that, delta L over L is equal to epsilon strain, and finally we can find sigma stress. Part B, we have different tracks with 10 meters length and 3 millimeters gaps. In this case, we just developed a compatibility equation. CE is equal to gap is equal to deflections that close the gap minus deflections that open the gap. Deflections that close the gap are in fact thermal deflections. We calculated delta L is equal to alpha S delta T L. We calculated based on this equation. Deflections that open the gap in fact are deflections due to the forces that are generated here in the opposite directions and intend to open the gap. Delta, because of these forces, is equal to PL over AE. And finally, we can say that P over A sigma is equal to 38.2 MPa.